Hi everyone. In today's tutorial we are going to explore some advanced RAG techniques and how you can use them in your projects. By the end of this video you will have a clear understanding of these methods and how to integrate them seamlessly. So let's dive right in. First, let's talk about what RAG is. RAG stands for Retrieval Augmented Generation. It's a smart way to combine search capabilities with large language models or LLMs to make responses more accurate and relevant. This is especially useful for things like chatbots, virtual assistants, and systems that need to provide detailed, factual answers. The model starts by getting relevant documents or passages from a large database based on the query. This usually involves a vector database where context embeddings are stored. The model picks the most relevant documents, typically at the top few, for the next step. Next, these documents are used to add more context to the original query. This extra context helps the language model generate better responses. Finally, the enhanced input, which is the query plus the retrieved documents, is fed into a generation model like GPT-4 to produce the final response. For more detail about the basic RAG pipeline, you can check out my Simple RAG chatbot repository link in the description below. Now let's dive into some advanced RAG techniques. The world of advanced RAG techniques provides a variety of tools. Instead of just giving you a standard blueprint, it provides a toolkit for creating customized intelligent search solutions. However, in this section, we are focusing on better index retrieval methods. The key here is to store and retrieve vectorized content efficiently. The technique one is sentence window retrieval. This method improves search accuracy by embedding individual sentences and including nearby sentences in the search. This gives the LLM a richer context for generating responses. To set it up, we first break the text into smaller sentences and store them in a vector database. We also including the context of the sentences before and after. During retrieval, we get the most relevant sentences along with the surrounding context. The next technique is auto-merging retrieval. A simple approach can lead to fragmented chunks of context. To fix this, we use an auto-merging heuristic to combine smaller chunks into larger ones, ensuring a more coherent context. Here's how it works. Identify a hierarchy of smaller chunks linked to larger chunks. During retrieval, if many small chunks relate to a larger chunks, we merge them to form a comprehensive context. In simpler terms, documents are split into smaller pieces. If multiple small pieces are related, they are combined to form a full context, which is then presented to the LLM. These methods focus on granularity and expanding the context. There are many other techniques out there, but these are some of the popular ones. Next, let's talk about evaluating different RAG techniques. Choosing the right methods for your RAG pipeline depends on your use case. You need to try and evaluate your RAG pipeline to see what works best for you. Each RAG pipeline has three main parts: query, context, and response. The query is the user input, the context is the retrieve information based on the query, and the response is the LLM output based on the query and context. We can evaluate a RAG pipeline in two main areas. Context relevance, which is refer to how relevant is retrieved context to the query, and answer relevance, that is referred to how relevant are the responses to the query. To sum up, the in-text retrieval techniques we discussed are methods to improve context relevance, which is turn makes the answers more relevant. That's our ultimate goals. For more detailed information and discussion about evaluating RAG pipelines, be sure to visit my GitHub repository linked in the description. Thanks for watching, and I'll see you in the next video.